this is Marcus at Evolution MV, or EMV for short. This is an introduction to the PIC operating system. What is PIC? I actually get asked a lot. Now you can read this here on Wikipedia. I'm showing you the article there. But I know what you get out of it. You get about as much as I got out of it. When I was learning object-oriented programming many years ago, I read everything I could get my hands on. None of it made any sense. None of it worked for me until I actually did it. Then I understood fully. So you can see where you can get this information. That's just for your edification. I'll tell you what it is. You'll understand a lot better. PIC is what would be called today a legacy system, and is often lumped in with things like COBOL and Fortran, even though it's quite different. Much newer and still under fairly wide and heavy use and development in order to keep up with things like web interfaces, mobile devices, encryption, etc. In fact, PIC is more akin to SQL than anything else. But in the beginning, PIC was a computer operating system like Windows and Linux. In fact, unlike Windows and its DOS and VAX predecessors, PIC was seen as the only serious competition to Unix. PIC was more mature and much more powerful than DOS ever was, but it was also more affordable and more accessible than Unix or VAX, and it later ran on commodity hardware like the IBM PC and clones. Today, however, PIC is just another server process running on Windows and most types of Unix, such as PostgreSQL or Apache or mail servers, web servers, whatever you've got. And while it's still known as PIC, it's more properly known under its umbrella moniker, multi-value, but we'll come back to that. The name PIC actually came from its primary progenitor, Dick Pick. No jokes. PIC began life as a system called Girls, which was developed by Dick Pick and Don Nelson in the late 60s, about 50 years ago now, for the Army via TRW. TRW is an interesting company. You should look them up right there. And it was for the Army's upcoming Apache or Cheyenne helicopter. It got canceled. It would later become the Apache. But while the program was canceled, the design ideas in Girls followed Dick Pick, who later reworked them into the Reality operating system for Microdata Corporation, 1973, 44 years ago. It's been a while, but they were good ideas. This would set the pattern, by the way, for the continuation and evolution through a series of competing distributors, vendors, and hardware manufacturers. Like I said, PIC was an operating system. It was written in assembler for each system that it ran on, but they were all pretty similar to the users, and that was the idea. This was pretty much the beginning of the write once, run anywhere philosophy popularized by Java. That's right, PIC did it first. Wherever one firm failed, and they did, two others, or so it seemed, would spring up in their place. Microdata, for example, was bought by McDonnell Douglas, the aircraft manufacturer that would later be bought by Boeing. But this spun off Reality, which still exists in England today, and you can buy it if you want to. And from this would collectively come JBase and OpenQM, or indirectly spawned these two, and these are relatively new additions to the multi-value community. They came in around 1991, which is about the same time Java popped up, so they're contemporaries of Java. This is, like I said, new and recent development, but the PIC model was in place and much more mature, much better developed. Java has gone through a lot of growing pains in the meantime, while things like OpenQM and JBase, they were pretty much written in stone. They were very well developed. They were very solid. Let's bring one of these up and show it to you. JBase, right there. Nice speedy internet. Don't you love it? So that's JBase. You can look up everything you want to. You can look up the online documentation. You can even download a demo. So we don't want to have that going too much. That's nice of them to offer us all that sound, but we're creating our own here. So we'll just mute that. Thank you very much. So anyway, Dick died in 1994, the year I first got involved in PIC programming, but his son Mark Pick is still active in the PIC community. And PIC is still around today, still in the mainstream, used by many large companies such as like Men's Warehouse, Rainbird Sprinklers and Irrigation System, Ferguson Plumbing, ADP, Cigna, Epicor, My understanding is, either Caterpillar or Cummins uses it. A lot of big players are involved in this, and they use it. They just don't go around advertising it, but then they don't really advertise the other things they use either. If they're using Oracle, it's Oracle who's out there touting it, not any of these companies. They don't go around advertising, hey, we use Oracle. And a lot of them don't. It's just too expensive. A lot of smaller firms use it too, precisely because it is so powerful and so affordable. I started my PIC programming career at a company called Dynix, provider of library automation software to about 2,000 libraries around the world. And that was a big client list, and they made a lot of money out of it. They made some other mistakes that cost them their future, but I used to regularly see their system in libraries that I frequented. Like the one in Idaho Falls that my kids went to all the time. I don't see it so much lately, mostly because the web has made it, libraries in general, unappealing to me. I just look things up that I want now. There are some very big vendors in PIC too. IBM, for example, was the world's largest PIC vendor for about 10 years. Then they sold it, and there have been some interesting home bases to PIC too. Dick Pick and Don Nelson, they operated out of Irvine, California, which remains the ancestral home to PIC. But the Boston area, or one of the towns out there, Newton, Massachusetts, they're like a second home. That's, I think, where VMart got their start. Denver is where Unidata got its start, and Rocket Software, I think, is actually headquartered there right now. England and Australia have become second homes to PIC. Germany figures in prominently because Siemens Nixdorf was one of the big original PIC vendors. So why haven't you heard of it then? Interesting question. I think it's mostly because of PIC's many firsts. It's been around long enough to move from operating system to server process. That kind of tended to relegate it to the back burner. You now hear more about the hosted or the hosting software, like Windows or Unix. You don't talk so much about internet service, ISS, or any of these things. Only programmers know about things like Apache, right? So, also, it's been around to the point where it has branched into lots of flavors. You really only have one flavor of Windows, but for example, analogous is Linux. Look how many distributions of Linux you have. Who's heard of Slackware anymore? You never hear of that. People talk about, if you know anything about Linux at all, probably Ubuntu or Mint, which is what I use, by the way. There are currently 8 flavors of PIC extant. The most popular is probably Universe. They have the lion's share of the market. It's currently owned by Rocket Software. Recently voted the best flavor of multi-value, however, is JBase, originally of England, then somewhere around Portland, Oregon, or Seattle, Washington, something like that. It's currently also owned by Zoomsys in Irvine, California again. The top of the line, in my experience, is Unidata, which bears a strong resemblance to Universe. In fact, they've been considered stablemates for over 20 years now. There's a flavor of multi-value that's actually Mumps under the hood. Mumps is another competing, basically, file system that was created about the same time as PIC was, and it gained a lot of traction in the medical and hospital industry. Now they have reworked it to look and act more like PIC. It runs PIC code. Another emulated flavor of PIC is Onware, which is actually Oracle/SQL underneath, but it can pretend to be PIC system. And it does that so that it can integrate better with other clients who use Oracle or SQL-based software that they just can't do without, and they want it to integrate more tightly with their PIC stuff. So the strange thing is, even Microsoft has its own flavor of PIC called Access, the name of which comes from one of the more powerful commands in the root flavor of PIC, which is D3 or Advanced PIC. Those who remember that, the last baby brainchild of Dick Pick. Before he died, he started this company out in California, Dick Pick and Associates. They consulted with Microsoft to create Microsoft Access, which is really PIC with a very, very nice GUI on it. Then there's Open Insight by Revelation. I actually have used that. Very nice. Integrated development environment, runs only on the PC. They had briefly a Linux version. They ditched that pretty quickly. Now they have a web interface, which is, I think, absolutely brilliant, and it can use almost any backend too. It can talk, by the way, directly with Lotus Notes, which has always made me wonder whether Lotus Notes was also just PIC too. OpenQM is my personal favorite. I use it all the time on my own system. Univision may still be around. I don't know for sure. I don't think I've ever even seen it actually in use. There's still about a dozen development suites and other tools. Unidata is practically married to System Builder, which the last time I used it still had both a CUI and a GUI. A CUI is a character interface. It uses the monospace fonts on the screen, the old text screen. Binary Star sells Nebula, a RAD front end. Zoom Assist now sells Accuterm, which has a fabulous GUI front end that you can use, and I have used it at a couple of clients. It's just wonderful. You wouldn't even know you had PIC. It just looks like another Windows program. Unfortunately, there's not a Linux one yet. I've heard rumors that it's in the work, but we've yet to see anything. Let's see, Accuterm is also my favorite terminal emulator, by the way. With the exception of a very limited capability Android version, though, it's only available on Windows. And I have to use Windows at work, though I'm a die-hard Linux fan. It's a curious side note that Microsoft, by the way, has been chasing the PIC multi-value brass ring since its inception. That's not widely known. BASIC was the first programming language they offered. They used to be a Unix vendor, by the way, the largest Unix vendor on earth. They had a product called Xenix. They also had a programming language, Microsoft BASIC, used it a lot. But it turns out the reason they were selling BASIC was because BASIC was the de facto standard for programming back in those days on the big professional machines, and the big professional machines were the PIC machines. In fact, all the home computers of the era, the Commodore, the VIC-20, the Atari 800 and 1200, they all had these BASIC interpreters that were their dumbed-down version of the PIC query language and programming language in one. It's kind of interesting that Microsoft was doing that. Their WinFS, by the way, industry pundits rumored that it was actually the PIC file system, but Microsoft couldn't ever pull it off, so they ultimately abandoned it. Besides, you already have all these other flavors with Windows versions, and they use containerized data, so why worry messing around with that? Microsoft really was barking up the wrong tree there, I think. I currently consult, by the way, for a major medical equipment manufacturer who currently uses JBase, but who began their operation on microdata reality. The founder of the company actually wrote some of the programs himself. On the other hand, as I said, I have OpenQM at home. Yes, I program at home because this is what I do, and that's why I'm making this video. I write housekeeping utilities OpenQM, and I like it because A, I get it for free. It's mine. It's an open source version, and OpenQM is the only one that's available in an open source version. It meets all of my modest needs. It's much more powerful than any of the other scripting languages I've used, at least for my purposes. It has fantastic string handling. I can make it behave pretty much like any other flavor out there. So whenever I do any prototyping at home, which I do fairly often, I can make it behave like the system I have at work, and then I can simply transport the code. And in the process, I make sure it's cross-platform compatible. If it runs on my system and it runs on their system, it's likely to run almost any system. But of course, I've taken some other measures that will make sure it's cross-platform compatible, and we'll get into that. That's part of what this whole series of lessons will be about. I like to keep my code flexible. But back to the name multi-value. It hails from PIC's once unique distinction that, unlike any other database, it stored data in groups of however many records would fit in a group. And the group paralleled the disk sectors, or clusters actually. And the number of records that it could fit in there would be influenced by how big each individual data record was. You know, one person's name will be longer than another's, and depending on how long the data is, you can fit more or fewer records into a group. But one of the crucial things was it didn't waste any space on space, which is one of the huge problems in, say, the DOS file system. If you save anything, it's going to take up at least one sector. It can't help it. But we'll come back to that. Then this data was delimited, just like a Windows text file is, which is normally delimited with a carriage return and a line feed, or just a line feed, or just a carriage return, depending on the platform and your editor and whatnot. That delimits the text. It says this line ends here, the next line begins there, and your text editor knows how to format that for you. But when it writes the record to the disk, it's all strung together in one long string, just like PIC does, but not other databases. Other databases, especially in the day, padded all that information with space, or they wasted all the space at the end of the sector, like I said. PIC overcame those limitations. You got more data in less space. You got more performance with fewer disk reads and writes, and disk reads and writes were the expensive, time-crucial thing. The more you could avoid that, the more performance you were going to get out of the system. So trimming the trailing spaces also had sort of a rudimentary data compression effect, allowing more data to fit into less space, but more importantly, clustering as many of these records as possible into groups whose size was then tuned to the underlying hardware. Coupled with hashing, it proved to be a stunningly fast storage and retrieval method for the time. So what's hashing? Well, where other databases, including Windows and Unix's file systems, must look up the physical location of the file in an index, multi-value simply turns the name of the record ID into a number. That number tells it what group it's going to find the record in, and that group is tied to a specific location on the disk. All this is calculated before the disk is ever even accessed, eliminating a couple of reads every time, eliminating a lot of time wasted. Nowadays, with all the RAM we have available, entire databases get read into RAM and accessed and updated there, so this feature is diminishing value. But other databases have also benefited from hardware and software improvements like faster disks, data compression, even encryption. And yet PIC remains one of the best performing databases, especially for large data files. So this model clearly has some oomph left in it. It has something to bring to the party, and I love it. But in my humble opinion, neither its hashing or its multi-value data storage are the real brilliance. Anyone can, and some have adopted similar designs. What no one else seems to see the value in but me is what I think really makes PIC still great today. Now, I know this is going to sound insane to all you computer science grads, but I was trained and worked for years in the same technologies you've come to view as essential, even gospel to your professions. I once programmed in assembly. I once programmed in C and C++. I worked at WordPerfect Corporation. Yes, helped write WordPerfect, DrawPerfect, PlanPerfect. I worked on I worked on so many things. I worked on GroupWise when it was still WordPerfect, and we were, by that time, programming entirely in Windows and C++. But I also worked on the Sonos. I was working on their character UI and motif GUI versions of all the programs. I translated them into German, or helped the translators translate them into German. So I've been there, done that. I wrote TSRs. Do you remember TSRs? That wasn't lightweight stuff. I wrote TSRs for DOS because we needed them at WordPerfect. We had to identify exactly where on the screen what character was appearing that shouldn't be there. And sometimes you couldn't always tell what it was, so I had this little crosshair that would pop up, zero in on that character, and it would tell you exactly its position and which character it was in and which code table. So I've been there. I've done that kind of thing. Trust me. Well, maybe you shouldn't trust me too much, but you're going to learn to trust me over the course of these lessons. And I also even programmed in Smalltalk in school. I programmed in Pascal at school. I'll tell you more about that later. I programmed in Commodore Basic as a kid, Microsoft Basic and Visual Basic as an adult. I've been there. I've done all that. And I even endured the COBOL and Fortran classes in computer science. Then one day, with a lot of help from a very malevolent and marginally illegal competitor, I won't name specific people's names, you can probably guess, the bottom dropped out of WordPerfect. And I wound up escaping to Dynix, where I got my first exposure to PIC. It took me a few months to get the file system, mostly because of the guys that I worked with. They were either librarians who just didn't really understand it in the first place, or they were old PIC guys who didn't work on anything else, and they just had no frame of reference. They couldn't understand where I was coming from. They didn't know what they needed to tell me so that I would get it. But I had this other paradigm fully in my head, and I couldn't understand what they were doing. None of it made sense. But when the lights came on, oh my gosh, I was like, where have you been all my life, PIC? And that's why I'm starting this YouTube channel. I want to give others the help that wasn't available to me. I've seen a lot of other programs making the transition from platforms and languages and get completely corrupted by the traditional restrictions from the 60s and 70s mostly. One of my favorite sayings is, we don't build ships in little green bottles anymore. You've got to get rid of that 80 by 24 green screen mentality that I still see a lot of people stuck in. I do all of my work on my own systems. Its screen size is like 240 by 73. I've written spreadsheets that exploit all that screen real estate. I've got all kinds of wonderful tools that they don't work in 80 by 24, and they don't work in monochrome. I have full color, got all kinds of nice effects. It works. Customers love this kind of stuff. They wish they could get more of it. I'll show you how to do that. And coding practices too. I mean, this is one of the big debates ever since that document, Go To Considered Harmful. Oh, it's not just harmful. We'll go into structured programming versus object-oriented programming, what the heritage of both is, what the strengths and weaknesses of both are. You'll get a full computer science course out of all of this. Aren't I generous? Granted, there's a fair amount of raw talent or lack thereof involved in these matters, but on-the-job training is not training, and it's not the way to go with new programmers. And you do need that talent. I recommend you look up an online book called, let's look up there, that would be a good one for you to see, Hackers and Painters. Right there, Paul Graham. Excellent. I highly recommend this book. Spend some time reading it. You'll understand a lot about the computer science industry and programming and programmers. Makes a lot of sense. And he makes the case that computer programming should be removed from the mathematics and science department and moved to the humanities and arts departments. And I think he's making a very strong case. I'll tell you this, I didn't start out in math and science as much as I loved mathematical and scientific things. I was an artist at heart. I would write poems, draw pictures, paint. The thing I loved most about cars and planes was their art. I learned metallurgy and balance points and thermodynamics purely accidentally. It was the art of those things that I love the most. I have an artist's soul, and you'll probably see that. So even the seasoned programmers, I think I have to say, are my target audience. I've seen a lot of them struggle with local practices and limitations that hobble their productivity. I recently worked for a major supplier of government aircraft fasteners, go figure, whose system would not allow record locking. Can you imagine it? I mean, how do you work on a system like that? I mean, we could have developed a workaround that would have worked and been very elegant, but that was kind of taxing for everybody who was working on the system, and the system administrator was kind of covering the whole thing up by spending a lot of his time with tools that he had developed over the years, and I mean years, we're talking 20 or 30 years, to patch these problems that were caused by the fact that you couldn't do record locking. So you had a lot of conflict and collision. It was just insane, and these guys get locked into working with these kinds of things, and it makes for some very bad programming habits that really they can't get out of. And how do you then fill out a resume and go to a job interview and say, well, gee, I've never done record locking? That's insane. And I can teach you how to deal with things like that. And for everyone, we'll be covering the coding, the code design. Yes, there is such thing as code design techniques that'll let you develop the large systems in little time the way PIC was meant to do. That's really the whole point of PIC. Like I said, I worked at WordPerfect, I worked at Novell, I worked at some other pretty big companies that, I don't know, I think it's probably wise I don't mention their names, but I have watched programmers, entire teams of programmers struggle. I've got friends at Microsoft, got friends at Google. They tell me their tales, the things they have to deal with, the development directions the companies are going. It takes an entire team of programmers to create a bar that you can slide left and right on the screen to resize the different areas of the screen. It's insane. PIC was designed so a single programmer could develop an entire system, and this is kind of crucial because in engineering school. I went to engineering school in Germany, where a lot of the Porsche and Daimler engineers come from, as a matter of fact. And one of the things we learned that very first year is some of the highest praise you can ever give to anything that was ever designed or built by anybody is every part looks like it was designed by the same person. You never heard that before, have you? You've certainly heard KISS, keep it simple, stupid. You've never heard this about every part being designed by the same person. There's power in that. And PIC gives you that kind of power because it lets you develop more and faster so that one person's hands or oversight is over more of the system. You have more control over it. You have more say in the design. It all works together much better. It'll make fantastic things. But you do need some training in how these things are done best, as well as an understanding of what PIC really is. So, just to close this lesson, with a brief overview of the philosophies and applications of Dick Pick's model, including all the things I was calling brilliant beyond the multi-value data model, as well as some criticism things I think still need improving. So the first thing you're going to see is my Linux Mate desktop. So let's minimize everything. Oh, looky there. I got Windows, and I want to show you that too. And I have got that arranged so that you don't see this is VirtualBox, by the way. I use a lot of virtualization. I still occasionally have to run Windows XP, or I have to run other distros of Linux. I'm even working on getting a, believe it or not, an iOS machine, or excuse me, an OS X machine going in here. An Android emulator, because I have to use all these things at work, and I don't want to have separate machines. I use one machine to do everything. But I don't run my database on this machine. I do have a database on this machine. In fact, I can run it here if I want to, and I'll show you that. This is the menuing system. You can create all the menus you want. Look at that. Using Wine, I can run Microsoft Excel. Linux is wonderful. We'll talk about all that later on. Here are my various Windows virtual machines. I can run Windows anytime I want. So I can run my OpenQM. Like I said, I like OpenQM. I can run it locally right here on my machine. And I can access my server from anywhere in the world, but when I'm at home I have to do this internally, so we'll do that. And of course I'm not showing you my password. I would have it automatically log in, but the password has to remain a closely guarded secret. By the way, if you go to my website, and I mistyped my password, but if you go to my website, and I will show you the name of my website, I can talk a blue streak, can't I? So let's go over here to my website, and that is www. Not when I'm at home, it's not. It is 10.0.0.245. Thinkware.com. That's me. Go to Evolution MV, talks more about there. But you can also contact me. There's the email address. There's the phone number. You can contact me and ask for access to the system. I will vet you. Nice new word that has recently been added to our vocabulary. And you can be one of my students, and I can show you how to program in OpenQM. Now, mine is set up to go straight to the Linux prompt, so we have to go to QM. Now, being the system administrator, the owner of the system, this is the root account, or what's called the system account. If you do who here, that's who I am, QM, the master system. You, as a typical user, will never see this on any system that you ever work on, because the system administrator should, A, make it impossible for you to do so, and 2, they should create a login script that automatically carries you to where you need to be. So I'm going to log over there. We're going to go to the EMV account. Remember, this is Evolution MV, and this is a little quirk of my system. Don't need to worry about that. Now my software detects the environment, and it detects my screen size. Look down in the bottom corner here. Like I said, I work in some extended screen modes, 191 by 67, just because of the font size here, hoping it can be visible to you guys. But this is a program that I wrote that allows me to determine my screen size when it's not always obvious. And you see down there the terminal emulator I'm using is GNOME Terminal or Mate Terminal, and it's in Linux mode emulation. So I just hit enter. I can clear the screen. I can list the master dictionary. Yeah, you don't know what the master dictionary is, but we'll cover that. Let me run another little program to show you the kinds of things I work on here. ANSI color picker TST. And it helps if I spell it right. It's one of the problems with longer names. It allows me to pick and choose whatever colors I want to use. Let's pick something really insanely radical here, shall we? Look at that. How do you like those colors? I hate them. So let's try something else. And we'll go bold and black on white. There we go. Now this is one of the standard pick commands, list, EMV dev, that's my programming file. QM, unlike most other picks, offers you this little menu at the bottom to ask whether you want to just suppress pagination altogether. Go to the next page. If you suppress pagination, it just rolls through to the end. 557 records. Well, I've been a busy boy, huh? So anyway, that's what pick normally looks like to you. Doesn't have to be. I've got another one. TED TST. This is my list program. It allows me to list things. Screen colors aren't the most conducive to visibility, but I'm going to press Control A. It's in debug mode right now, which is why you see this little panel down here. It shows me some details about what's going on. The scroll bar is not currently active. It will be, but it gives me a good idea of where I'm at within the full list. See that? You like that? And look at the menu down here in the bottom left. If you have a keypad, your cursor keys don't work or whatever, watch this. You hit the slash, and it changes the keypad from numbers to cursor action. So anyway, for me, on this terminal emulator, my up and down arrow keys work, left and right arrow keys work, page up, page down, end, home. They all work very nice. In fact, I can do this. Shift down and flag multiple items. Now it's not flagging these because, as you can see, they're a very light gray indicating they're inactive. If I hit the escape key, no longer selected. Notice the title up at the top. That's the name of the program, or the calling program that calls this routine so it can demo it. Every program, every routine I write a driver program so that I can test it. Because that's one of the things I do professionally right now is test software. And I have to test it to death to make sure it does everything it should do. And I test it on all kinds of systems. I've been testing it on the Linux virtual terminals, for example. I'm not going to go over there now because I don't know that my screen capture software will capture that. But I'm going to find some way to do it. And I have tested this over there, and it works beautifully over there as well. Which is important because it's really a completely separate thing. It works very differently. Now I'm going to press Control A. You know Control A. You can use it on Windows. Whenever you're in Control A, what does it do? Or in a text or anything. When you press Control A, it selects everything. Watch this. Everything that can be selected is selected. And notice the color of the highlight bar. When it's in the selected items, it's a bit darker than when it's in the inactive items. You can do a lot of things like that. And notice the colors of my debugging panel over here. You get full color control. This is not a case of the old style black and white. You really get full control. Like I said, like I showed you earlier with the color chooser. Notice the mnemonics right here, underlined and bolded. Now, this only works on certain terminal emulators or in certain emulation modes. There are others that don't work that well, and I'll show you one of those now. Let's hit escape. Well, it still took those colors. That's kind of sick, huh? So we're going to go over here to my Windows machine. This is Windows 7, nice and rudimentary. And look at that. Gosh, why is it doing that? It's restricted to a small screen size. Now that's completely new, and it's because it just installed a bunch of updates. So we'll go full screen. Should still record. I'll find out later if it doesn't. I'm using AccuTerm. AccuTerm is my favorite terminal emulator. It just works well. It can emulate just about any terminal you might want. Okay, except for like the IBM series, and there's licensing reasons for that. But it'll emulate the most common ones. So what am I doing? Okay, kick me off. You should kick me off. You did. Okay, let's try that again. Internal. Network connection refused. Oh, look at that. I broke it, didn't I? So we will go to reset connection. Oh, it's not going to let me connect. I can't believe I did that. It's completely hung now. Well, you got a brief overview of PIC and what PIC is right there. And I broke my SSH server right there in front of you. Shame on me. I've done that before too. Reset the terminal, reset the connection. It's probably still not going to work. Nope, it does not want to work. What a pity. I may have to remake this video. Refused. That's interesting. I don't do that very often. So let's do this. Let's try and open another internal session. Nope, it's not going to accept it. Well, that's as far as we're going to get today. So I've introduced you to the history of PIC, who uses PIC, what PIC really is. It's a database system. It's a file system is what it really is. It's a file system that is now inextricably married to a programming language that is just brilliant. It has lots of wonderful things to offer you. And one of the things I find is most brilliant about it is that, and you know what, we will get out here to a file browser, and I will show you some of my code. Okay. Now we're not going to see any of the wonderful anything, apparently. There we go. Now you don't get to see any of the wonderful syntax highlighting. I'll show you that next time. It's wonderful. But if you look here, something you'll notice right away. See all my variables? All these variables? Notice what you're not seeing, especially right here. Do you see any dollar signs, percent signs, anything? It's just variable names. These are typeless variables. Typeless variables, like I said. I was raised in the Nicolaus Wirt tradition of strongly typed languages. I was raised in the object-oriented tradition. You can't have variables like this. This is the greatest evil on earth, right? Well, guess again. In 1994, once I finally got what was going on with PIC, I never looked back. I have been able to program my heart out. It doesn't take entire teams of people to develop anything. Typeless variables are one of the reasons. Now, a criticism, PIC isn't perfect. Nothing is. I have a couple of bones of contention with PIC. One is, it's not entirely typeless. There is one other variable type, and that variable type is a file variable. As highly developed and powerful a language as this is, I just don't see why it should be necessary to open a file to a variable before you can read from it or write to it. You should just put the name of the file and the record ID there, and you should be able to read and write. It's as simple as that. That needs to go away. Then there are the record IDs. All of the data within a PIC file is multi-valued, which means it looks more or less like a text file like this. But you can divide the lines with multi-value marks. So you can make essentially a 3D table, a 4D table if you want to, even 5D I have seen. You can do that kind of madness. The problem is the record IDs do not allow the multi-value marks. And I've seen people use all kinds of characters that are just anathema to the host operating systems that all PIC systems are now running on, except of course for D3, which can be configured to run more or less beside the operating system rather than on the operating system. So it can do its own thing in its own disk space. But programmers have a habit of using things like colons and asterisks and slashes, things that the host operating system just doesn't want to see. Now, as long as you're using the record IDs inside a data container, that's not going to cause a problem, but the problem is that we have very good integration now with the host operating systems, and you're always having to run some sort of conversion utility. So what people have done is they have fallen back to the dot, the period. Well, that works, but the fact is that both Unix and Windows do regard the dot. Look up the Linux file name specifications. With Windows, you know you have the dot and those last 3 or 4 characters. That's your file extension, and the operating system uses those to associate data files with programs. And it's a problem. When you've got more than one period in there, it can confuse the operating system. I've seen it happen. And this is kind of important. This is the last thing I'll say about PIC. Its model was based on Star Trek, believe it or not. They actually admitted that they were playing this Star Trek game. It was an early adventure game, ran on an IBM 390, I think it was. And it occurred to Dick Pick that, oh my gosh, the Star Trek computer, that is the model of computer that we really want. That's how it should work, with some variations. And this gave him the paradigm for the entire UI. And you saw me execute some of those commands. I just list the file. That's not hard. You understand that. I can teach my kids to do that, right? And I do teach kids to do that. The query language is very simple. It's very forthright. It's very logical. Something that's not widely known, especially in our age of GUIs, is that back when the character line or command line interfaces were being developed for Unix and for Windows by extension, they actually brought in linguists to help them to understand what made more sense to human beings, especially back in the days. For example, let me tell you the story of Alan Turing. He's famous for having invented the whole idea of symbolic computing, and that sounds very awesome and everything, except what we're really talking about here is variables. Right? Variables. That was a breakthrough? Well, yeah, back in those days, when computers were a completely different beast than they are now, the concept of being able to put in an equation of c squared equals a squared plus b squared, that was kind of groundbreaking news to them. Nobody had thought of this. It was, like I said, they weren't artists. They were a bunch of mathematicians, and you turn a bunch of mathematicians loose on a problem and you're going to get a mathematician's solution, and that's usually monstrous to everybody else. But these things, as they get developed, Alan Turing just makes this one little chain, and all of a sudden everything's better. Well, Dick Pick came up with this change that created the paradigm of English, or really any language, but he called it English because he speaks English. And then he patterned the entire user interface after it. Unix was busy doing the same thing at the same time. The idea is that in English, or in any language, we have dictionaries, and dictionaries define things. And the definitions that will be in our dictionaries are the 2 major parts of any computer system, which are data and programs. Data is a noun. Program is a verb. Verbs work on nouns, so any sentence is going to have verbs and nouns. And then you're going to have the data definition dictionaries. The actual data itself is going to have what Dick Pick called attributes. Thus, in any database, let's say customers, they're going to have a first name, a last name, a phone number, an address, an email address, who knows, all of these things. Those are the attributes of each customer. Those attributes are what other database systems call fields, or in a text file would be a line. You can create a dictionary item, and I will show you this in the next video, a dictionary item to help you list that data on the screen. You can think of the dictionary item as being very much like a spreadsheet. Let me show you the spreadsheet. It's a very good analogy, actually, when it finally starts up. There we go. Come to us Excel. Okay, see these headings here? Now imagine you had a formula in there, because we can do that. We can format the cells and we can declare them to be, for example, date. We want this to be that kind of date right there. Everything that's in there will be that kind of date. Well, where does Excel hide that stuff? Well, Excel actually hides it behind all of the cells, but in PIC we would, for all practical purposes, for argument's sake, we would hide it right there behind the B. So you could list all the data, listing B, and it would list all of those dates in the format you chose. Now I can't show you that right now. We'll get to that. But it's a brilliant way of making the structure of the query language and the organization of the computer seem linguistically obvious to the people who will be using it, unlike the way that the mathematicians of Alan Turing's day did it. So this paradigm of the English language, of dictionaries, of descriptors, definitions and formats and data layouts, it was all very obvious to people. It made it possible for just anyone to sit down at the computer and issue a command. List all the customers who have spent over $100 million this year in Australia. And it would list it out. And I think this is one of the other brilliant things about PIC, and we'll get into this too, is the UI design. Just as an aside, I'm a big critic of UI design, especially in the age of the web and phones. It seems to me that the marketing managers have been turned loose and they've run amok and they've created a bunch of mayhem. When I first saw the Macintosh in 1984, I watched a little girl follow her father into a computer store. I think she was like 6 or 7. And with no training whatsoever, in under 5 minutes, she drew a picture of a fish and she printed it out on paper. She took it home with her, with scales on it. Bubbles coming from its mouth. This was incredible. I had never seen anything like that. I was just starting my computer science career back then. I was amazed. I mean, the things that I was going through in school, the things I had to learn. I watched this little girl walk in and walk out with that picture. I was astounded. That was the power of the GUI back then. Because the GUI, well designed, mostly at Park Place by Xerox, it was obvious. You didn't have to explain things. You saw a trash can in the corner. You knew you'd throw things in the trash can, they were gone. You saw the printer. If you drag it to the printer, it prints out on the printer. These things were obvious. You almost didn't have to tell people. Nowadays, we've got elements all over the place, and nobody knows what these things mean. You can't look them up in a dictionary, especially when it's on your phone. Who knows what some of these things are? Where do you find something here? Search, that's about the only thing you can look for. Gift cards, registry, weekly ads, and very often you've got them in 2 or 3 different places. We probably have them down here too. Why? Oh, what is this? What happened to the pull-down menus and the English words that tell you what things do? The pictures are great, especially for shopping, don't get me wrong. But look at some of the software on your phone. How much effort did it take you to learn how to actually use the thing? The format of the thing makes it next to unusable, and they seem to have this mentality that they want to use signs and symbols that you can't look up. You can't even hover over them like I hover with a mouse here. Are we going to get something to pop up? There we go. Got a pop up there. It doesn't really tell me what it is. You can do that on a PC, but on a phone you can't do that because you can't hover. The best you can do is touch, and then it's done. You don't have anything to look them up in. It's not written in a word that you can understand. You have to try everything, figure it out, learn how to use it, maybe even go to a training class. Are we really back to that again? A menu with words that you can read, and it explains things, and user elements, control elements that make sense, that you know what they do just by looking at them. We need to come back to that. PIC will offer you that, because that text GUI, that CUI interface, when it's properly done, It's beautiful, it's fast, it's powerful. And I know the argument can be made, well, if you take this GUI interface here and do it correctly, it works well too, but nobody does. And one of the problems is that the web browser is itself limited. It has its own control elements for its own housekeeping things. It can't give you full control because it would relinquish control of those things. Then you can write add-ins and plugins that will give you better control. But what do you do with something like a phone? And now these companies are following this madness of looks the same everywhere. Whatever runs on your phone, it has to look and act the same way in your web browser. Are you kidding me? Now they're taking away the option to have at least this much control? It's going to go from bad to worse, and we're going to start seeing a lot of people rebelling, and maybe a few marketing managers hung out to dry because they really shouldn't be saying anything about software design, and certainly not user interface design, and now the interesting professional twist of user experience. Well, that's all for now. I'm going to close this down and get ready for the next lesson, where we're actually going to go into how you create data and represent data and list data, manipulate data, and I hope you'll get a lot out of that. We'll even get into a bit of the programming because we're going to write a program that will help us to manipulate that data, to change it wholesale, and then dictionary items that will let us see the changes that we've made. So